Contrary to what their name might imply, black holes aren't just vast areas of nothingness. A black hole is an astronomical object whose gravitational pull is so strong that nothing can escape it, not even light. Known as the event horizon, the surface of a black hole marks the point where the speed required to escape is faster than the speed of light. Once radiation and matter are in, they're in it for the long haul. But how close is the nearest one to Earth, that we know of? It turns out it's not that far in the grand scheme of things. Gaia BH1 is a mere 1,600 light-years away, in the constellation Ophiuchus. This is 3 times closer to Earth than the previous record holder, an X-ray binary in the constellation Monoceros. Gaia BH1 was discovered in 2022 by the European Space Agency's Gaia Space Telescope. The find was made possible by careful observations of the black hole's companion, a Sun-like star orbiting the black hole at about the same distance as the Earth orbits the Sun. Take the solar system, put a black hole where the Sun is, and the Sun where the Earth is, and you get this system, said Karim El-Badri, an astrophysicist at the Center for Astrophysics Harvard and Smithsonian and the Max Planck Institute for Astronomy, and the lead author of the paper describing last year's find. This is the first unambiguous detection of a Sun-like star in a wide orbit around a stellar mass black hole in our galaxy. To investigate the system further, El-Badri and his colleagues used the Gemini multi-object spectrograph instrument on Gemini North, which measured the companion star's velocity as it orbited the black hole and provided a precise measurement of its orbital period. Our Gemini follow-up observations confirmed beyond reasonable doubt that the binary contains a normal star and at least one dormant black hole, El-Badri said. We could find no plausible astrophysical scenario that can explain the observed orbit of the system that doesn't involve at least one black hole. The Gaia BH1 system is unusual because it contradicts scientists' current understanding of how black holes form. BH1 is massive enough to have become a supergiant early in its life as a star. As a matter of fact, it should have already grown large enough to consume its companion star long before it matured into what it is today. It is interesting that this system is not easily accommodated by standard binary evolution models, concluded El-Badri. It poses many questions about how this binary system was formed, as well as how many of these dormant black holes there are out there. Telescopes that can see X-rays, light and other forms of electromagnetic radiation cannot be used to observe black holes directly. However, by studying the effect of black holes on nearby matter, scientists can infer their existence and learn more. For example, if a black hole travels, yes, they can move, through a cloud of interstellar matter, it will accrete some of that cloud into itself. A similar process can occur if a regular star comes close enough to a black hole. As the star is drawn closer to the black hole, it risks being torn apart. Due to its increased speed and temperature, the attracted matter releases X-rays into the surrounding space, whose signatures astronomers can detect and use to identify black holes. New evidence suggests that black holes profoundly impact their local environments, whether by emitting powerful gamma-ray bursts, devouring nearby stars, or stimulating the growth of new stars in some regions while stalling it in others. Besides BH1, astronomers have identified a number of other nearby black holes. Ordered from the closest to the farthest, these include A0620-00, 3,300 light-years away. A0620-00 consists of 2 objects, a K-type main sequence star and a stellar mass black hole. The 2 objects orbit each other every 7.7 hours. Gaia BH2, 3,800 light-years away. Gaia BH2 is a binary system consisting of a red giant and what is very likely a stellar mass black hole. Gaia BH2 was originally discovered as a black hole binary candidate in 2022, alongside Gaia BH1. MOA 2011 BLG 191, 5,000 light-years away. OGLE 2011 BLG 0462, also known as MOA 2011 BLG 191, is a stellar mass black hole isolated in interstellar space, in the direction of the galactic bulge in the constellation Sagittarius. GRS 1124 to 683, 5,400 light-years away. The gamma ray and X-ray source GRS 1124-683, discovered by the Granat mission and Ginga, is a system containing a black hole candidate. XTE J1118 plus 480, 5,700 light-years away. XTE J1118 plus 480 is a low-mass X-ray binary in the constellation Ursa Major. It is a soft X-ray transient that most likely contains a black hole and is probably a microquasar.